Hello guys, welcome back to another video. In this video, we are going to learn about sorting in arrays. In the previous video, we already learned about how to search an element in an array. In this video, we'll be learning bubble and the selection sort algorithm. So let's see what exactly the sorting is. Sorting is a process of arranging the data in a particular order. Means if you are given with some numbers, like here in this GIF, you can see how the numbers are getting sorted in the ascending order. First 1 2 3 4 5 6 7 8 9, like this. These numbers are getting sorted. So this is what a sorting is. Sorting is nothing but arranging elements in some particular fashion. It may be ascending order or the descending order. Here you can see the example of the array which is sorted 10 20. Means you can say that if I pick this element, random element in the middle, I can definitely say that the element which is all the elements before this elements are smaller than this element, and all the elements which are on the right hand side of this element are greater. So this is what exactly the sorted array is. Now have you ever arranged yourself in the ascending order of your height during school time? है ना, स्कूल टाइम्स में लाइक प्रेयर जब होती थी, देन आवर टीचर यूज टू अरेंज द स्टूडेंट्स इन असेंडिंग ऑर्डर, यू कैन सी. So yeah, that was an example of the sorting. So now let's understand what is bubble sort. So actually the bubble sort is a sorting technique where we keep checking the adjacent elements if the first element is greater than the second. If yes, we swap them, otherwise we move further without swapping. अब ये जो पर्टिकुलर डेफिनेशन मैंने बोली है यहाँ पे, ये असेंडिंग ऑर्डर के सॉर्टिंग के रिलेटेड मैंने बोली है. लाइक अगर ये डिसेंडिंग में होती तो लाइक वी विल बी हैविंग सम चेंजेस इन दिस डेफिनेशन. So there is a fact why the bubble sort is called as a bubble sort. There is a reason behind it, and that reason is that the bubble sort get its name because elements tend to move up into the correct order like bubbles rising to the surface. जिसका मतलब ये है कि जब बबल सॉर्ट हम परफॉर्म करते हैं किसी एलिमेंट्स पे, तो ड्यूरिंग ईच इटरेशन जो सबसे बड़ा एलिमेंट होता है या फिर सबसे छोटा एलिमेंट होता है वो अपनी करेक्ट पोजीशन पे जाके बैठ जाता है. जैसे कि बबल जो होते हैं, जो बड़े बबल्स होते हैं वो पहले सरफेस पे आ जाते हैं, तो इन द सेम वे वैसे ही यहाँ पे जो बबल सॉर्टिंग होती है, तो इसीलिए इसे बबल सॉर्ट नाम दिया गया है. नाउ हाउ डज़ दिस बबल सॉर्ट वर्क्स? तो बबल सॉर्ट में कुछ होता नहीं है. जैसे हमारे पास एक कंप्लीट एरे होती है एंड वी कीप चेकिंग टू एडजेसेंट एलिमेंट्स. अब मैं अज्यूम करके चल रहा हूँ दैट वी आर sorting the elements in an ascending order. Okay, so if we want to sort the elements in an ascending order, bubble sort uses multiple pass through an array. Means we are iterating over an array multiple times. So this is what this multiple pass means. In each pass, bubble sort compares the adjacent elements of an array. It then swaps the two elements if they are in a wrong order. Means if we are sorting in an ascending order, if the first element is larger than the second, then we will swap. In each pass, bubble sort places the next larger element to its proper position. Means if we are talking about the ascending order, the bubble sort keeps the largest element at its correct position during each iteration. In short, it bubbles down the largest element to its correct position. So now let's understand the bubble sort with an example. Okay, so let me open the OneNote. Now here I am having this array 53291, and it is unordered array. As you can see that the elements are neither arranged in decreasing fashion or increasing fashion. So we are going to sort it in ascending order. Okay, so I'm ascending order में like इसको हम sort करेंगे. Okay, so please don't mind the handwriting. I hope you will understand it since I am drawing with a mouse. तो यहाँ पे like let's take example of the first iteration. So in the first iteration what we will do, यहाँ पे we'll keep two pointers. This is the p pointer suppose, and this is the q pointer. So what does this p pointer mean? P pointer means the current element. P pointer will always point to the current element, and the q pointer will always point to the next element of the current element. Okay, so the next element of the current element. Now we'll check if this element at the p pointer is greater than the element at the q pointer. So we can see that yes, it is greater. So what we'll do, we'll swap, because we want to arrange the elements in an ascending order, so we'll swap it. So I'm talking about the first pass. A pass is nothing but first iteration over this array for the sorting purpose. So first iteration is called as first pass. So this is pass 1, and in this we'll swap these two elements since the first element is greater. So the array becomes 3 5 2, 9 and 1, and we'll increment both the pointers by 1. So now the p will point here and the q will point here. Now again we will check this element at the pointer p is greater than the element at the q or not. So we can see that yes, it is greater, so we will swap. So 3 2 5 9 1. So this is the latest array that we are having now, and both the pointers will get incremented by 1. So now sorry, this p will point to here and the q will point here. Now we will again check if the element at the p position, or we can say the p pointer, is it greater than the element at the q position or the pointer. So we can see that it is not, so we are not gonna do anything, we are not gonna swap them, we will keep the array as it is. So 3 2 5 9 and 1, but the pointer will increase by 1. So now p is pointing here and q is pointing here. Then we will again check if the element at the p position is greater than the element at the q position. So we can see that yes, it is greater, so we will swap. So the latest array become 3 2 5 1 9. So you can observe that the element which is the largest element inside this array has got its correct position, because it is moved to its correct position, that is the last position. Now we'll do the second pass number 2. So now the array which we are having is this one. So let me write it again here so that we can sort it in second pass. Now again our p pointer will be here, q pointer will be here. This pass 2 means second iteration. Okay, second iteration. So in this second iteration we will check if the element at the p position is greater than the element at the q position. So here we can see that yes, the 3 is greater than 2, so we will swap them. So it will become 2 3 5 1 and 9. So our pointer will also get increment by 1, so p will be pointing here and q will be here. So now again we'll check if this element is greater than this one which is at q. So we can see that no, so we'll not swap. So the array will remain same, 1 and 9, but the pointers will get incremented. Now p will be pointing to 5 and q will be pointing to 1. We'll check if this is greater than this one. So yes, it is greater, so we'll swap. So it will become 2 3 5 2 3 5 1 2 3 1 5 and 9. So now since p and q will get incremented by 1, now p will be pointing here and q will be pointing here. So we'll check if the element at the p is greater than 9 or not. So we can see that it is not. So this iteration is also complete, and you can see that the second largest element has got its correct position, that is the second last position. So it is the 9, it is 5. Now we'll go for the third iteration. So let's go for the third pass, which is the third iteration. So pass 3. Okay, so now let me write this array here, 2 3 1 5 9. So p pointing here, q is pointing here. We'll compare if the element at p is greater than q or not. So we can see that it is not greater, so we'll not swap them, we'll just increment the pointer values by 1. So 9. Now p will be pointing here and q will be pointing here. We'll compare if the element at the p position is greater than the q. Yes, it is greater, so we'll swap. 2 1 3 5 9. I hope you got the idea what I'm doing, and that's why now I'm doing it fastly. So yeah, we have swapped them. Now the pointer value will also get incremented. So now p will be pointing here, q will be pointing here. Then we'll check if the value at p is greater than q or not. We can see that it is not, so we'll not swap. So it will become 2 1 3 5 9. The pointer values will also get incremented by 1. So this is p, this is q. We'll check if the first element is greater than the second or not. So we can see that it is not, so we'll not do anything. Okay, so we'll not do anything, and this will be our resulting array in this pass. So now go for the fourth pass, and as you can see that there are 5 elements. We'll require 4 passes to sort the array completely. Let's see that if the array gets sorted in this fourth pass. So let me rewrite the array: 2 1 3 5 and 9. So this is my p pointer, this is my q pointer. I'll check if the first element is greater than the second. Yes, it is greater, so we'll swap to 1 2 3 5 9. We'll increment the value of the pointers by 1. We'll check if 2 is greater than 3. So since 2 is not greater than 3, we'll not do anything, we'll not swap, and we'll simply increment the values of the pointer by 1. So now pointer here, this is P, this is Q. We'll check, we'll compare. So we can see that the first element is smaller than the second, so we'll not swap. We'll simply increment the values of the pointer by 1. Sorry, I write it like a Q, it is 9. Okay, so the pointer value here, it is P, here it is Q. We'll check if the first element is greater than second, so we'll see that no, it is not greater. So finally this was the fourth pass, and we got our sorted array, which is 1 2 3 5 9. I hope you got a clear idea how this bubble sort is exactly working, and I also wanted to tell you the logic behind why there is a requirement of n-1 passes. Why there is a requirement of n-1 passes. So you can observe in this passes that during each pass exactly one element is getting placed to its correct position, which is the largest element. You can see that during this pass, the 9, which was the largest element, it got placed to its correct position. Now since this part is sorted, let me give the take the another pin. So since this part is sorted, we will be applying the bubble sort on this part. So now we have to compare this array. So in this array we can see that the largest element in this sub array is getting sorted to its correct position. In the same way, this array is sorted now. So since this array is sorted, here we left with this array. So in this array, during the pass 3, the third largest element got its correct position. So now our this complete array is sorted. This array is sorted. We left with 2 elements. So then finally we sorted these 2 elements. So in this way, this 2 is getting sorted to its correct position. So we don't require fifth iteration. There is a reason behind it, because the single element is always sorted. This is the reason. You can see that these elements are already now sorted during the fourth pass. So we don't require to sort this element, because it would obviously be at its correct position, because single element is always sorted. Okay, so this is the reason why we required n-1 passes for the n elements. We require minimum n-1 passes. Okay, if you want to run it more than this, you can run, no problem will happen, but it will just cost you much. Hence this is the reason why this bubble sort algorithm is having time complexity of O of n square. We'll see about it later, but let's now code this bubble sort. So here I have written the pre template like code. You can see that I have just created this array, which we taken an example here. The same array I have taken here, and the size is 5, so I have given the size 5. Then I will be creating this function bubble sort, which will be taking an array. So I'm going to pass this array there into that function, and the size of the array I'm going to pass. So n is nothing but the size of the array, I'm going to pass it. So let me also write that here. So array and the size. So I'm gonna pass this. Here I'm just running a for loop to print the array, because after this line the complete array gonna get sorted. Since we all know that array is like the name of the array itself is a pointer to its base location, so the array always get passed to the function by the reference. Okay, keep in mind this. So now I'm gonna write the code here. So let me run a for loop. As we can see that we are running this n times. There are 4 passes. So let me run this for loop I equals to 0 to n I plus plus. I'm not 0 to n, but 0 to n minus 1. Instead of I will be taking q, since I explained you the example with 2 pointer. One was p and the another one was q. So I'm taking them as a p and q. So this is q. As I already told you that q is a pointer which points to the next location, to the position to which this p is pointing, means q will be always p plus 1. Okay, so that's why I'm doing p plus 1 here, and now I'm doing q is less than n and q plus plus. So I'm closing this. Now these are the 2 for loops. This is the reason we cannot run the outer loop till n. Here also you can see that the p pointer is at max going till this n minus 2, because you can see that if this is the n minus 1th index, This is n minus 2th index. You can see that in the fourth iteration the value of the pointer p is going till the n minus 2th position. This is n minus 2th position. Will be running here n minus 1 because n minus 1 से less है. So इसका मतलब the value of the p will be n minus 2 at max. So now here we can see if the value of the p in the last iteration is n minus 2, then the value of the q will be n minus 2 plus 1 and n minus 2 plus 1, which will be n minus 1, which is the correct last index. So yes, we can say that we can run in such a way. Now we will be checking if the first element, means the element at the pth position, is it greater than the element at the qth position. Okay, we'll check. If it is true, we'll swap. We don't need to create this swap function because it is already created in the this beat/stdc++.h library. So we'll simply pass the two elements which we want to swap. So we'll pass these two elements of the array and it will swap those two elements. Now that's it. We are done with our bubble sort algorithm. Now let's try to run this program. So I'm running this program and let's see if we get the correct output or not. So here you can see that we got the sorted array 1 2 3 5 9. Let's try this with another elements. Like I'm taking the completely unsorted array 7 6 5 5 4 and 3. I also need to change the value of this to 6. Okay, now let me save and run the program and let's see what do we get. So here you can see that we are getting the sorted array 3 4 5 6 7 and 9. So which is the correct answer as well. So now let's talk about the time complexity of the this bubble sort algorithm. We'll also see that can we optimize its time complexity. So here, what is the time complexity of the bubble sort algorithm? So the worst time complexity of the bubble sort algorithm is O of n square, because the outer loop is running O of n times and the inner loop as well running O of n times. That's why the time complexity becomes O of n square. In the best case, the array is already sorted. Since the array is already sorted, you just need to check O of n times. I know that you are getting confused that in the code that we wrote just now, it will still be like working n square times even though the array is completely sorted. So we need to do some optimization and some modification in this, and we'll see that how we can do. But before that, let's see best case time complexity of the bubble sort. So in the best case time complexity of the bubble sort, it is O of n, and let's see how. Let me go back to the OneNote and here I will explain you. This was the example in which we exactly required n-1 passes, but there may be the case that the array will get sorted in just pass 3 and you don't even require further passes to do. So in that case, how that condition can be checked? So let me take a small example for that. If I could take 1 2 then I will take 4 and 5. So no, it is already sorted, so let me swap these two elements. So 1 2 5 4. So this is the array that we have to sort and it is almost sorted. 1 2, we just need one swap, but here you can see that there are 4 elements. So according to the algorithm that we studied, we require n-1, that is 3 passes. So we require 3 passes according to the algorithm that we studied. We'll keep this p pointer here and the q pointer here. We'll check if the 1 is greater than the 2. We'll see that no, it is not. So we'll not swap and we'll simply move the pointers p here and q here. We'll check if 2 is greater than 5. We'll again not swap. So 2 5 and 4. So p here, q here. We'll check if p is greater than q. Yes, it is. So we'll swap. So 1 2 4 5. So you can see that in the first pass only the array is sorted, but still we'll be performing the second pass, then third pass, and we will, our algorithm or the code that we just wrote will be running till n-1 times, even though the array has already been sorted in the first pass. So what will be that condition which will like stop us from doing this two iteration. So to stop these two passes, what we can do, we can keep a flag which will tell us if at least one swap has been done or not in that particular iteration. See, if no swapping is occurred, it means that the array is already sorted. So for that purpose we will do something. See, in this case array is sorted, but if we take this array in the second pass 1 2 4 5, and if we try to like do so, no swap will occur because the elements are already at their correct position. They are already in the correct position, so no swapping will occur. So we can keep a flag to check if at least one swap has been occurred or not. If no swap is occurred, we can break the loop and we can say that the array is sorted, and we will not going to do this further passes. So let's go back here and let me clear the terminal. I'm keeping one flag here. Inside here I'm keeping one flag, so it will be boolean kind of flag. So boolean flag, I'm assuming it to be false. False means no swap has been occurred. I'm assuming that no swap has been occurred by saying false. Okay, and now here I will check if swap occurred, I'll make it true. If swap is not occurred, it will be false only. Okay, it will be false only. So I hope you understand what I did. I created this flag which is initially having false. It is up to you what you want to store. You can even store true. We just need to check. Okay, so in this for loop I'm checking here if at least one swap has been occurred or not. So here in the at this point I can say if the flag is false, still false, means no swap has been occurred, because even after running this complete for loop, if the flag doesn't become true, it means that the no swap has been occurred. And since no swap has been occurred, I can simply say that the array has been sorted and you have to break the loop. So here I will simply check if flag still false. If flag still false, I'll simply break the for loop. And notice that this and notice that this break I'm doing inside this for loop, outer for loop. That's why this complete for the execution will get like stopped. This execution of this for loop will get stopped due to this break, and we'll go out of here. Here we will come, and thus we will stop excess of passes even after the array has already been sorted. We can check this by keeping a counter that how many times our iterations are running. So I'm keeping the counter here, I'm storing 0 in it, and here in this for loop, here this inside for loop, I will simply increase that count in order to check how many times we are iterating. And finally I am in the outer. At this point I'll be preventing that count /n. Okay, I'll be taking the same example that I told you here, 1 2 5 4. Okay, so let me change the size of the array to 4 and 1 2 5 4. So 1 comma 2 comma 5 comma 4. So according to the algorithm that we just saw, the value of the count should be 4, because we will only iterate once, and that's why we'll compare this one and this one. It may be 4 or 3, let's check. I'm not sure, but it will be 4 or 3. Yeah, you can see that 3 because we made 3 comparisons, one comparison, second and third. That's why it is having 3. So we can see that how much we reduce this due to this just keeping this flag. And let me remove this flag and let's see how many times it runs. Let's run the program and we will see that it is going to run 6 times. So this is a very small difference we can see at the size of the 4, but if you take the large sized array, this difference will also get increased. Okay, so we can do just simple little optimization here in the program. So now as we have done with the bubble sort, let's go and study about the selection sort. So what exactly the selection sort is? Selection sort is one of the easiest approach to sorting. It is inspired by the way in which we sort the things out in the day-to-day life. So n place means we don't require any other data structure to be used to sort this. We just require the given array, and in there only we can do sorting. We don't need to declare any another array to do the sorting thing. So how does the selection sort works? It finds the first smallest element and it swaps it with the first element of the unordered list. It finds the second smallest element and then it swap it with the second element in the unordered list. So I know that you are not understanding by just reading this statement. So let's understand the selection sort here. Let me take an example like this: 5, 4, 3, 2 and 1. So it is completely array is sorted in the descending order. Okay, so during the first iteration what we will be doing, inside this complete array, first of all our pointer will be here. Suppose this is our p pointer which is pointing to this 5. So now in this complete array, okay, in this complete array, what we will do, we'll find the smallest element. So we found that the 1 is the smallest element. So what we'll do, we'll replace this first element with this element. So our value will become 1 4 3 2 and 5. So at this point I can say that my at least one element is sorted. Now we left with this array. Since the first element is sorted, we'll not consider it. We are left with this array. Now in this array, our p will obviously p will get incremented. Now p will be pointing here, and in the leftover array means this array will find the smallest element. So we find that the 2 is the smallest element. So we will swap this element with this for p pointer. Okay, the element which is pointed by p. So this is as this 1 will be as it is. Now this 4 and this 2 will get swapped. This will become 2, this is 3, and this 4 will come here, and this is 5. Now we can say that these two elements are sorted. Okay, so these two elements are sorted. So this was the second iteration, and now let's take a third iteration. In the third iteration these two elements are sorted, so I'll bring them as it is. Now we're left with these array. So we need to sort this element. So our p will be pointing here. So since p is pointing here, we will find the smallest element in this array, and we found that the same element to which the p is pointing is the smallest. But still we need to completely traverse the leftover array, even though we are already pointing to the smallest element, because we need to compare them. We'll compare 4 with 3, then 5 with 3, and so on. We will find the smallest element. So we'll swap the smallest element with this p, which is 3 only, so it will remain as it is, 3. Now this will be the array after third iteration. Now let's go to the fourth iteration, and in this fourth iteration we can say that these three elements are already sorted. So we'll bring them as it is here, and we are left with this array 4 and 5. So in this 4 and 5 we will be pointing to this position, and we will find the smallest element out of these sub array, remaining array. So we found that we are already pointing to the smallest element. So we'll write the elements as it is. So now in the fifth iteration we found that we got this array, and we can say that 4 elements are already sorted. Now we left with the single one, so we don't need to sort it, because we know that the single element is always sorted. So this is how the selection sort work. During each iteration we find the smallest element in the leftover array, and we replace it with the first element of that leftover array, and by such way we can get the sorted array. So this is exactly the logic of the selection sort algorithm. So now let's see how we can code it. So selection sort.cpp, here I have created this template in which I have created this function selection sort, the same array and the size of the array. Here I am calling that function. So here I am going to pass the array and the size of the array, and यहाँ पे like I am just printing the array after sorting. Okay, so I need to take it as an input and the size as well. So now what I'm gonna do, I need to first run a for loop. Okay, for int, let me write it as p, and now let's get back to the OneNote and see what we were doing. We were traversing in this complete array and finding index of the smallest element we are finding, and then we are swapping the first element with that element. So do you know the logic of finding the minimum element in an array? If you know that, you can easily find the smallest element index. What do? We assume that the first element is itself a smallest element. So let's suppose I create the variable named min, and in that I will store the first element, which is 5 in this case, so I'll store 5. Now I'll keep comparing this mean with the next all the elements. I'll compare this 5 with 4. Is the 5 less than 4? No. So we will change this value of the min to 4, since 4 is minimum. Now 4 is less than 3? We'll see that no. 4 is greater than 3, so we'll change the value of the 4 to 3. Now our current minimum element is 3. Now we'll compare this 3 with 2. We'll see that the 2 is smaller, so we'll again change the value of the 3 to 2. So now no value is 3, the current value of the mean variable is 2. Now again we'll check with 1. We found that the 1 is smaller, so we'll change the value of the mean variable to 1. In such a way we will get the minimum element. So with the same approach, we'll be finding the index. We don't need to find the element, but if we found the element, we'll definitely gonna found the index as well. Here I'm creating one variable int min underscore idx, means minimum index. So I'm assuming that the minimum index is current element index, which is p. See, during each iteration the current element will be p. To the current element this p pointer will point. So that's why I'm saying that minimum index, let's assume that the p is the minimum index. Now I will iterate to the leftover array. So how I will iterate to the leftover array? Let's say j is equals to from p to j is less than n, and I'll do j plus plus. You don't need to run from p itself, because you have already considered that element in the min index, so it's not necessary to run it from here. You can also run it from p plus 1. So here I'm running a loop from j equals to p plus 1 to j is less than n. Okay, now as we have to find the minimum index, what we will do, we'll check if the element array of j means the next element. You can see that this is the current element, so this is the next element, p plus 1 I have stored there. So, okay, let me just change this j to q, just for the better understanding. This is q. In the same way like we were doing in the bubble sort algorithm, the q were pointing to the next element. So here also q is pointing to the next element, and we are comparing that next element with the current element. If the next element is lesser than the current element, which is the min underscore idx in this case, the index of the minimum element, we can see. We are assuming that the first element itself is the smallest, and then we are checking if it is true or not, and if it is not, we are swapping the values to get the minimum value. So here we are checking if the second element is lesser than the current element. So if it is true, means the minimum index will update to the queue. By the end of this running this for loop, I'll be getting this minimum element index. So since I'll be getting this minimum element index, I'll swap that element array of min underscore idx with the current element. So current element is array of p, so we will swap that element with this. So by doing this, and eventually we'll get the sorted array. Now let's try to run this program and check if we are getting the correct output or not. So you can see that we are getting the correct output 1, 2, 3 and 5 and 9, so which is the correct answer as well. So now let me change some elements to 98, 12, 3, -1, 23. So here I have taken these random elements, and let me try to run the program, and you can see that the elements are getting sorted correctly: -1, 3, 12, 23 and 98. So this is how selection sorting algorithm works. Now let's see the time complexity and if any improvements that we can do into the selection sort. The best, worst and the average, all time complexity for the selection sort are n square, since doesn't matter what is the order of the given array is, whether it is already sorted or it is jumbled. So in all the cases we need to find the smallest element for current position. So for that purpose we need to traverse complete array. So that's why the time complexity of the selection sort algorithm in all the cases, best, worst and average, it is n square. So it is like n plus n minus 1 plus n minus 2 and so on. So it is nothing but the sum of natural number. That's why I'm saying n into n minus 1 by 2, and the time complexity becomes O of n square. Now why this n minus 1 and then n minus 2? It is nothing but first we are iterating n times. Okay, here first we are iterating n times, means this array. For finding the smallest element, we are iterating over this complete array, then to this array, and then to this array, and then to this array, and then finally 1. So this is how we are iterating first n times, then n minus 1 times, and then n minus 2, and so on up till 1. So that's why this is nothing but a sum of natural numbers, and which is the time complexity of the selection sort algorithm as well. So I hope you got the concept of the selection sort algorithm, and now you can code by yourself. If you get any doubt or any problem, you can comment in the comment section below. Thank you so much for watching the video.